a look at how to integrate this format. Integral of square root of a squared minus x squared with respect to x. We know that x is equals to a sine theta. Now, given that x is equals to a sine theta, the x, the theta, is equal to a cos theta, and the x will be equals to a cos theta d theta. Now, with this done, let's make our variable change it from x to theta. So, making our substitution, this becomes a squared minus x squared is a sine theta squared multiplied by the x, and the x is now a cos theta d theta. Now this becomes integral of square root of a squared minus a squared sine squared theta multiplied by a cos theta d theta. Now we know that sine squared theta plus cos squared theta is equals to 1. Therefore 1 minus sine squared theta is equals to cos squared theta. Now factorizing by a squared, we'll have 1 minus sine squared theta multiplied by a cos theta d theta. Now we know that 1 minus sine squared theta is equals to cos squared theta. Therefore this becomes a squared cos squared theta multiplied by a cos theta d theta. Therefore you know that this tends to a cos theta multiplied by a cos theta d theta. Therefore we are integrating a squared cos squared theta with respect to theta. A squared is a constant. It can be moved behind the integration sign, and we'll have a squared, and we'll be left to integrate cos squared theta with respect to theta. Now, do we remember when we are integrating powers of sine and cosine? And we know that cos squared theta is equal to 1 over 2 into 1 plus cos theta. 1 plus cos 2 theta. Therefore, a squared, let's make our substitution of cos squared theta to give us 1 over 2 into 1 plus cos 2 theta, if we're integrating with respect to theta. Now, with this done, we can bring another 1 over 2 outside again, so we're left with a squared over 2 integrating 1 plus cos 2 theta d theta. Therefore, this becomes a squared over 2 integrating 1 with respect to theta, we have theta, and integrating cos 2 theta, we will have sine 2 theta over 2 plus c. Now, from trigonometry, we understand that the sum double angles, that sine 2 theta is 2 sine theta cos theta. Now we can rewrite this now to give a squared over 2 theta plus 2 sine theta cos theta divided by 2 plus c. Therefore, a squared over 2 into theta plus sine theta cos theta plus c. This is the format of the answer of integrating the square root of a squared minus s squared with respect to x. However, the work is not yet complete because we have to find the terms for sine theta and also for cos theta. We recall that the substitution we are making is x is equals to a sine theta. Therefore, sine theta in this case is equals to x over a. Also, theta in this case is equals to arc sine x over a. Now, what then is cos theta? We recall that sine squared theta plus cos squared theta is equals to 1. We know that sine theta is equals to x over a. Therefore, this becomes x over a squared. And we know we are looking for cos squared theta, and this is 1. Therefore, cos squared theta is equals to 1 minus s squared over a squared. Factorizing this now, taking the LCM, cos squared theta is equals to 1 minus x squared divided by a squared. Now we take square root of both sides. Taking square root of both sides, we'll be left with cos theta, and we'll be having square root of 1 minus x squared divided by a squared. Therefore, cos theta is square root of 1 minus x squared divided by a. Okay, I think we made a mistake. From the LCM here, taking the LCM of 1 minus x squared over a, you will have a squared minus x squared divided by a squared. Therefore, square root of cos square theta is cos theta, and we will have square root of a squared minus x squared divided by a squared. Therefore, cos theta is the square root of a squared minus x squared divided by a squared. That's the square root of it. And the square root of this is equal to a. Now, we have been able to evaluate what cos theta is. We have also been able to evaluate what sin theta is, and also what theta is. So we can make our substitution, right? And we understand that integral of square root of a squared minus x squared dx will be equals to a squared over 2 theta. Theta, which is arc sine x over a, plus sine theta, which is x over a, multiplied by cos theta, which is what we have here. Which is multiplied by the square root of a squared minus x squared divided by a plus c. Now, simplifying further, we realize that it becomes a squared over 2. Let's open the brackets, and we have arc sine x over a plus x over a multiplied by a squared over 2 multiplied by square root of x squared minus x squared divided by a plus c. And this simplifying further, we have a squared over 2 arc sine x over a plus x over 2 multiplied by square root of a squared minus x squared plus c. Now, we now have an expression to solve for this form of integration. So, with this, we can take any question in this format. Let's begin with integral of the square root of 16 minus x squared dx. Now, to rewrite this 16 minus x squared in terms of a squared minus x squared, we know that 16 is equals to 4 squared. So this is written as square root of 4 squared minus x squared with respect to the x. Therefore, in this case, a is equals to 4. So we apply this principle. Applying the principle, we have that our answer is a squared over 2, that is 4 squared over 2, arc sine x over a, that is x over 4. Remember, we are applying this principle, plus x over 2 multiplied by the square root of a squared, that is 4 squared, minus x squared plus c. Now this becomes 8 arc sine x over 4 plus x over 2 square root of 16 minus x squared plus c. Let's take another example. Integral of the square root of 4 minus x squared dx. Now let's rewrite this again in the format of a squared minus x squared, and that will give us 2 squared minus x squared with respect to x. Therefore a in this case is equals to what? 2. In the same way, we are going to apply this principle. So let's apply the principle. Revising the principle, this becomes square root of a squared minus x squared integrated with respect to x is equal to a squared over 2 arc sine x over a plus x over 2 multiplied by the square root of a squared minus x squared plus c. Therefore, we can say that the square root of 4 minus x squared dx is equals to a, which is 2 squared over 2 arc sine x over 2 plus x over 2 integral of 2 squared minus x squared plus c. Now this is simplified to give 2 arc sine x over 2 plus x over 2 square root of 4 minus x squared plus c. Now we can have more and more examples of this form, but the main principle we are going to keep applying is this format. That square root of the square root of a squared minus x squared, when it is integrated with respect to x, we will have a squared over 2 arc sine x over a plus x over 2 arc multiplied by the square root of a squared minus x squared plus c. Now next video, we'll be taking a look at how to integrate 1 over a squared plus s squared, and this time we'll be using a substitution of x is equals to a and theta.